Algebra 2, we're doing our Unit 10 review for our test tomorrow. It says the graph of log base 2 of x is shown if h of x is a transformation of f of x as shown in the graph below. What is the equation of h of x? Okay. So look, it started, the middle point is right here at 1, 0, right? And now the middle point is right here, okay? So what happened? It moved 1, 2, 3, 4 to the right, and then 1, 2, 3, 4, 5, 6, 7 up. Okay. So it went right 4, up 7. Okay. Now that's the transformations. Okay. But they want to know the equation. So our equation, when we write it, is f of x equals, my bad, h of x equals. Now the original is log 2 of x. So log base 2 of x. Now let's remember, the insider right here is going to lie and be the horizontal change. The outsider is not going to lie, it's going to be the vertical change. So what's my horizontal change? Right 4. Now right 4 usually means plus 4, but it's an insider, so it's going to be a lie, minus 4. Okay? And then my outsider is the vertical change, up 7, it's going to be up 7. Okay, so remember, insiders lie horizontally, outsiders do not lie vertically. Cool. That's it. What is the equation of the asymptote? Now remember, for these logs have a vertical asymptote. Okay. So I'm looking at h of x over here. It's going to go up forever this way, but this is going down, and it is never going to touch this vertical line right here. All right. So there you go. So what is that vertical line? So that vertical line, that h of x is going down and never touching, goes through this number right here, which is 4. Okay? And since it goes through the x-axis at 4, you put x equals 4. Okay? For the vertical asymptote. Vertical asymptote. What's the domain and range? Now domain is x, range is y. So start with the domain of h of x. So we already said that the vertical asymptote is at 4. It never touches 4. So my x values have to be greater than 4 without being equal, because it doesn't touch. And it goes forever to the right. So we could say that x is greater than 4. All real numbers greater than 4. Not equal, not underlined, just greater than 4. Okay. Now the range, it does go down forever. It does go up forever. So the range is all real numbers. Y is all real numbers. Cool. All right, and that's for logs, all real numbers for the range every time. But the domain has to be greater than the asymptote. Okay. Notice the relationship between this asymptote and this domain. Cool. All right. Rewrite the exponential equation as a logarithmic equation. Okay, so let's remember how to do this. We write the word log. The base is the base. What it equals to is my argument, and that equals the original exponent. Okay? Same thing here. Write the word log. The base is my little base. What it equals to is my argument in the parentheses, and that equals the exponent. Remember, the exponent is the answer when you turn it into a log. Write the word log. The base is the little base. What it equals to is the argument in the parentheses. The exponent is the answer. Cool. All right. Now you can do it backwards. Rewrite each log as exponential. So now we start with the log. So we're not going to write a log. We're just going to write the base as the base. What it equals to is the exponent. And that equals the argument that was over here. Bam. Now we need to remember, ln, natural log, really means log base e, okay? So this really means log base e 4 equals x. Well, once I know that, then I know the little base is the base. What it equals to is the exponent, okay? And that equals, right? Cool. Now remember, if it's just a log, if it's just a log, that means log base 10. Okay, so this really means log base 10. Cool. So the little base is the base. What it equals to is your exponent, and that equals what the argument was. I apologize that the thing is not working right now. Cool. All right. Now we need to solve these. This is like 10.5, but we can definitely do this, right? So what are we going to do? We're going to turn this into a log. So I'll write the word log. The base becomes the little base. What it equals to is the argument. And that equals what I had for the exponent. Oh, this pen isn't working. Not. Okay, here we go. Cool. Now this left side, I need to put in the calculator, see what I get. Log base 4 of 20. So remember, in your calculator, you go to add a calculator. And to get log, it's right here next to the number 1. You do control 10 to the x right here. And again, we had log base 4 of 20. So log base 4, go to the right, 20 is 2.16. Equals 2x plus 1. And now you just solve it like a normal equation. We subtract 1, you get 1.16 equals 2x. Horrible. And then to get rid of that 2, we divide. What's 1.16 divided by 2? 0.58. Cool. Same thing here. You got an exponential equation. So I'm going to write the word log base 2 of 400 equals the exponent 9x. Can I put, goodness gracious, come on. Can I put log base 2 of 400 into my calculator? I got 8.64. And the last step to get rid of that 9 that's being multiplied, I need to divide by 9. It'd be cool if my pen worked. Why not just... Okay, whatever. Killing me. Alright, divide by... Okay, cool. So 8.64 divided by 9. 0.96. Oh my gosh. Come on. Zero point 0.96. Cool. Last one. Now, if there's something being multiplied out front, you can first divide on both sides to get rid of that. So I really get 2 to the x plus 4, and then 100 divided by 5 is 20. Okay. Once again, I can do log base 2 of 20 equals x plus 4. What is log base 2 of 20? 4.32 equals x plus 4. I can get rid of that plus 4 by subtracting 4. Now when I subtract 4, I'm going to get 0.32. All right. Let's do this. All right, so number 7. So we want to break this up. Okay, so if they're being multiplied, we can split this into 2 logs. Okay, so log base, and so remember, when you split it, when they're being multiplied, you turn it into 2 logs that are being added. So, the sum. So the first part of the multiplying is 3. So log base 4 of 3. And again, it turns into adding because you're multiplying inside. So the other one is going to be log base 4 of, and then x to the 10. Cool. Now, so you can clearly see what a is going to be. But the other one, it's just supposed to be x on the inside. But b is some number out front. Well, here's why. We learned in 10.3c, when you have an exponent, you can pull it out front, right? So that's what we're going to do. So that 10 is going to go out front. So I'm going to rewrite the first part, log base 4 of 3 plus 10's out front now, and then log base 4 of x. Anytime you have an exponent, it pulls to the front. So I know 3 goes here, and then what's in front of my log base 4 of x? 10. A equals 3, b equals 10. Okay, this was our 10.3a and 10.3c assignments at work. All right, well, let's simplify this thing. Do we have the same basis for all these logs? So if it's ln, 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 yeah, those are the same logs. They're log base e. So first off, if I see subtraction, I know I can, turn that into one log that's going to be divided. Okay, so the 2x will be on top, the 4y is going to be on the bottom. Cool. Bring this down, plus natural log 5c. All right, now when I see addition, I know I'm going to bring these together into one natural log, and addition is going to multiply 5c with this fraction. So it's going to multiply with just the top. 2x times 5c. 2 times 5 is 10. X and c are just going to go right next to it. Cool. Holy moly. So we're going to get 10xc on top, and then the 4y is going to stay on the bottom. Now the question is, can we reduce this fraction? And 10 over 4 does reduce to 5 over 2. That is our final answer. Cool. So make sure you reduce if you can. Let's simplify this. Now this time we're not expanding it, we're working backwards to bring it into 1. So first off, if there's a number out front, that's going to be the exponent on the inside here. Cool. So this is really log base a to the 5. And this one's really log base b to the 10. And then remember, subtraction means you bring it into one log with division. So a5 on top, b10 on bottom. That's it. Okay. So that's using 10.3b and 10.3c. Cool. All right, last one. Same idea. All right. Now, there's something out front. There's something out front. There's not something out front. So all we're going to do is make sure that this goes to this power. So log base 3. Now, what we have is x squared. X squared to a power of -3. Okay. So when you have a power raised to another power, they're going to multiply together. Log base 3 of x to the -6. Okay. Bring this down. Plus log base 3 of x to the 5th. Now, we have the same base. Same base here and here. So that means we're going to combine them into one log that's being multiplied. So log base 3 of x to the -6 times x to the 5th. Okay. Now, when you multiply the same base, you add those powers. So it's really going to be log base 3, if my pen will write, log base 3. And then when you add -6 plus 5, you get x to the -1. And your last step, if you have a negative exponent, you got to put it under the number 1. 1 over x is what x to the negative 1 is, okay? All right, so again, negative exponents go underneath a fraction bar. And that is it.